Mm, cool. So, any doubts from the previous time?
One small doubt.
Go
Like
on.
basically the commands section, like all the commands and stuff will be in a separate space in the memory array, right?
Yeah.
So like and the variables part will be in a place called stack in the memory. But like
Yes.
stack is a kind of a data structure of sorts, right? So like how exactly is the command stored in the array in the same way? Or
What do you mean by stack? See, there is the stack is there in your mind. For computer, it's just continuous data. I hope we are clear
okay,
with that.
okay, yeah, fine. You're basically saying it's just stored as an array. We are understanding how it's implemented as a stack or
Yeah.
something like that.
Yeah.
Okay, thank you.
Cool. So I will do a different format today because I think this will give me more horizontal space to write. So yeah, a few misconceptions that you people had. This is the stack with the stack frames. EBP is here and ESP is here at the moment. And the code section I'm drawing in parallel. So let's say this is main. Or okay, never mind. This is uh, a main called F called G. So this is G, and EIP points somewhere over here. So this much is fine, right? Like you all understand how this, and I hope please take notes this time because like it becomes very hard to keep track of what's happening, where it's happening, and why things are happening. Uh, yeah, cool. So this would be EBP of the previous one, basically this value, and above that would be the EIP of the old one. This much is clear to everyone, right? Cool. So now we move on to how arguments are stored. So as Abiza pointed out last time, this is main, this is F. I'll label it as the stack. This is whatever else we had to store over there, and this is F. Now, before you do a call, you need to prepare the arguments on the stack. There are conventions. I am telling you the sanest and the most popular one, and it's the most popular because it is the sanest. So, in the code section of main is here, let's say something is there. You don't need to worry about what's happening in main. Let's focus on F. Yeah, so you have the instruction call G over here. Is this clear? So before that, let's say G takes three arguments, A1, A2, A3. So the first, so the way uh, the the arguments to be pushed on the stack are uh, push A1, push A2, push, sorry, my bad. Yeah, A3, A2, and A1. A3, A2, and A1. The reason they are done in the opposite direction is because it makes finding them easier. I'll show how that's done. In any case, so we assume that all arguments are 4 bytes, because see, in the end there are only two types of arguments. It's either an integer or it's a pointer. If it's let's say a boolean or a character or anything, pad it. So like make it if it's 1 byte, make it 4 bytes and then push it on the stack. So this much is clear, right? Like the push instructions. Now we'll go through how uh, what happens at each point of time. So EIP is here. Now this instruction hasn't been executed. Now A3 is pushed. So EBP, ESP. Once A3 is pushed, A3 comes here and ESP moves down. Push is clear to everyone, right? Hmm, cool. Uh, so A3 is pushed. Next A2 is pushed. Next A1 is pushed. Yeah, I am recording. So you see the top right. If this isn't there, just tell me, because yeah, this is the recording indicator. And then A1 is pushed. So ESP is here now. And EIP moves here. Now call hasn't been executed yet. So we are about to execute call, and now we executed call G's, let's say here GK instructions. So the stack frame creation, this happens. So this is, let's say, push RBP, EBP, my bad. So after call, this is the EIP, the old EIP. So I'll annotate it with F so that you know which function it belongs to. I think this would make things clearer. Uh, this will be EBP for F, and then move EBP to ESP. That's the next instruction. So ESP is here. Now EBP is also here once that instruction gets executed. Then you create the stack space for which function is this, G? Yeah. So beginning here you have the stack space for G, and ESP is shifted down. Sub ESP comma 0x10, because I'm just going with that value. So a couple of things now. The very first one is why it's pushed in the other order, and why in this sense at all. Uh, so first of all, you need to know something called addressing modes in assembly. So if you ever see an instruction like push EBP, this means you write it to you write the value of EBP. Okay, so let's say EBP was 0x10. So you write the value of 0x10 to the stack. Now let's say EBP itself was pointing to some particular location. So its value was, I mean, 0x10 is also a valid address, first of all. 0xFFFF, a lot of Fs, 48. Okay. So this looks something like a memory location, right? Even even this is a memory location, just that you most likely wouldn't be referencing that. So if you have a push brackets EBP, this means you do you push star EBP. You dereference whatever is at EBP. So whatever is at this memory location, let's say that's 0x19. Then you would write 0x19 to that address. Is that clear?
Oh, can you repeat it again?
Yeah, so in the instructions, if you instead of having push EBP, you have push brackets EBP. It simply means uh, dereference that value. So take EBP as a pointer. So this would be something like you have uh, int, yeah, int EBP. In the first case, you do star ESP is equal to EBP. I'm writing C code over here because I think that would be easier for you to understand, easier for all of you to understand. ESP plus equals 4. So this is fine for the first one, right?
Yeah, yeah.
Now, the way this works is int EBP somewhere above, star ESP is equal to star EBP, and ESP plus equals 4. That's the only difference. The star is the only difference. So you basically dereference whatever is there at ESP. You treat it as a pointer. Now you don't dereference integers, so it would be something like, in if I have to write exact C code, star star is this clear? So this is a typecast. I hope all of you know that.
Yeah.
Yeah, so
Could you explain the C code for the previous one, where you
what's
wrote star ESP, the
yeah
second step?
yeah, what's wrong in this? What do you not understand in this? Isn't this this is how
Uh,
push, once again, is this is how push works, right? In general,
so like over here
listen.
is ESP a pointer?
Yes, ESP, all registers act as pointers. ESP pointed here. This means you wrote it here. This means you shifted it down. This much clear?
What is
Yeah,
star
I'll
imply?
think on.
One second, one second. One of you. So, Karthikeya, you go first. Is that clear?
So like actually like when you say star ESP, you're basically getting the value that ESP points to, right?
I am rewriting it.
Okay.
You know
Okay.
how you know how pointers work, right?
Yes, yes.
Yeah, exactly. This is so if ESP is a pointer and I have to change the underlying value of the pointer, how would I do it? Star ESP equals EBP.
Okay.
Yeah. Now and then I move ESP. So yeah, Thiru Kailash, you also had a doubt. What were you saying?
What does star imply here?
Dereference, right? C code. You read the C guide, right?
Okay, okay, it's clear.
Yeah, that's it. So now this is a typecast. If you all remember the C guide, and I hope you read it properly because that was the reason I gave it to you. This means I am so EBP is of type int. This is saying take it as int star. So take it as a pointer. dereference that pointer. So the first step is, so this entire thing is saying get this value somehow. Then do the same thing to the stack with this value instead of this value. Is that much clear? Guys, any doubts in this? Because like this is important. This will get worse. If this syntax isn't clear, the syntax is going to get worse. Yeah. So this is the first form.
Could you
Now the sec
explain why you put
yeah.
instar ABP?
So I am doing it just for C consistency. If you have int EBP and then you do a star EBP, the compiler would give an error. Now, see, you get the philosophy, right? Like the thing I'm trying to do. Don't, this is a syntax, this is just syntactic. But the thing is, I'm basically reading the value at EBP, then seeing where it points to in the memory, and then reading that value.
Okay, fine.
That much is clear to everyone, right? Leave the
Oh,
syntax.
once more, please.
Yeah, okay. EBP is some separate dabba in the processor. This is the memory. EBP points here. Okay.
Yeah.
Hmm. This thing is some value. My question is, what is stopping you from taking this value as another index?
Okay, fine.
So, for all practical purposes, it could be pointing here or here or
Okay.
whatever the value is inside. Now, when I dereference it, I basically say get this value, then get this value.
Yes.
Yeah, so this is the first form of addressing mode. So the brackets just imply that instead of reading EBP value, read the value which is pointed by EBP value.
Okay, okay, fine, fine, fine.
Uh, Anyone else having any doubts in this? I think this diagram should make it really clear.
And just one more thing. Why are you typecasting it over there by using Instar?
See, bro, try dereferencing int in a open God board. Not don't even open God board. Open online GDB. Try dereferencing. So you have a variable int EBP. Try doing star EBP and see what the compiler tells you.
Okay, but so you're saying even if the thing which EBP points to is a address type, but it still would be of the type int, and you can't dereference
Yes,
it.
yes, yes. That's just for
Okay,
type consistency. I assumed all
okay.
of you people read Beach Guide, but like I think some of you did not properly do that. It's fine. Anyways, so this is the first addressing mode, just brackets. Wow, perfect. Mm, so this is clear, right? Next one is push, and this is not specific to push. You can use it anywhere. Let's say some constant value. It has to be a constant. Brackets EBP. Any guesses what this would be doing? Yep, offset. No, no, no. Push. Push always happens wherever the. See, if push happened at arbitrary addresses, it would be very, very, very hard. So what it does is, what Abizar said, it offsets. Why do you think we need this? To access variable, to access arguments, both variables and arguments. Oh, sorry, plus plus. It will be plus here. Because we will be storing variable with respect to offset in mem and not with names, obviously. Yes, that's right. So every variable for you. So if you do move RAX, EAX to minus 0x8 EBP, so what does this mean? Write val at EBP minus 8 to other way. Uh, Y plus. Once again, guys, I think you people forgot again. Higher memory addresses on the top. So you have the stack. So args come higher than EBP. True. This is a variable then. This is a local variable. Yeah, Manu, you're right, but like this is a local variable. I'm not writing to arg. So yeah, EBP. So EBP minus 8 would be here. EBP minus 4 would be here. So this would write whatever the contents of EAX are to here. This is similarly, if you have to access arguments, what would you do? So just a couple of notes. Uh, Keep these things in mind and ignore whatever the C code above was. Push, that was just for demonstration. EBP minus 8 has the value of EAX now after the move has happened. Yes. So first of all, uh, current EBP in any stack frame, while while you are in the middle of the function and not during the creation or the destruction. Give me 1 second. Current EBP points to old EBP. Uh, yeah, so current EBP points to old EBP. Uh, Current ESP points to nothing, garbage value. And isn't it the other way around? Like EAX will have the no. I don't know what syntax you're seeing, but like no. Okay, you might be getting confused in the syntax. This is GNU. This is AT&T syntax. This is like CP, SRC, DST. AT&T syntax works this way. I think you all are seeing Intel syntax. Yeah, so that is a confusion. Long story short, it doesn't matter. One value gets moved to the other. Right now, assume that EAX is getting moved to this, and I'm following this convention because this is simpler. Okay.
That's what I told, right?
Yeah.
EAX is moved to EBP minus 8.
So whatever the value of EAX is moved to here.
Okay,
No.
yeah.
So the value of this is copied to this is what I mean.
Value of AX is copied to
this.
EBP minus 8. Okay, fine, yeah.
Yeah,
Hmm.
cool. So current EBP points to old EBP, current ESP points to garbage. This is when stack frame is complete. If you see the flow, you will be able to see how this is happening. So when you push anything at all, wait, this might be wrong. I'll come to this. Mm, so when you do a push, after the push ESP starts pointing to that value. Push A implies ESP starts pointing to A. So ignore the above C code. It was just for an illustration, but I hope you got the point. So ESP points to A. That's clear, right? After a push. So you can see how this is happening. Uh, so the first thing you did was push RBP, push EBP. So now ESP points to EBP, ESP points to old EBP. Then you did a move EBP to ESP. So now both ESP and EBP point to this. And then you sub it. So now move ESP to EBP, right? No, once again, source to destination. This is during stack frame construction. Yeah, SRC is ESP. No, SRC is EBP. See, EBP is getting moved. EBP goes from some value A to whatever value ESP is holding now. Because new EBP is current ESP. That's true. Yeah. So SRC, no, bro, run CP command in terminal. Run CP command in terminal. I'm being serious right now. Destination is where you go to. Okay. Destination is where you go to. SRC is the current thing. SRC is source, right? Yes. You go from source to destination. So the destination in this case is ESP. This is a different level of conversation people are having right now. Anyways, you okay, I'll clear move once and for all, I hope. What is GDB? We'll come to that. We'll hopefully use GDB in today's session as well. Hmm. Now A has some initial value X. A gets the value of B. No, this is AT&T syntax. Intel syntax is the other way. I should. Yeah, that makes sense. Thanks, Abigail. Uh, AT. This should be clear for everyone now, I hope. Yeah, so where were we? So you can see how EBP comes to point to the old EBP, right? During stack frame creation, and then sub 1 second. Hmm. It actually points to some variable, but like let's not go there. So before stack, the board is giving me real pain today. Push A implies ESP points to A, star ESP is equal to A. Finally, after everything is over, ignore the C code above. That was for an illustration of what's happening. They both happen simultaneously. Just go ahead, Karthik.
Yeah, so like when you do push A, basically you get A's address in the stack, right? So shouldn't it be
A's
more
A's
like,
A's value.
okay,
See,
so
okay,
when you,
depends on what you're pushing. Once again, depends on what you're pushing. It's complicated. So there are multiple methods. We will come to what exactly it means. So let's say some value. So whatever the new value is that will be on the stack will be pointed to by ESP. I get your doubt. I think you mean what if it's a register, right?
yes, yes, EBP or something.
Yeah. So let's say some value. So ESP points to that value. Okay. I,
Yeah,
I will
fine.
I will come to your exact doubt once we are a bit further in addressing mode. So push means this. Now stack frame creation. Okay. Now I'll go here. So when you do okay, this is the code section and this is the stack frame. I am drawing it separately so that it becomes easier. ESP is here. It points to something. That something is also very important. I'll cover that next. So you do a push EBP. So now that something after this, that something is above still. Now the EBP ka old value. This is pointed to by ESP. Then you do a, so you understand how the flow is going, right? Now you do a move EBP to ESP. See the syntax in the comments. You get this old value plus EBP plus okay, nothing. Yeah, now both ESP and EBP point to this. So after push EBP has happened, this is the situation. After move EBP to ESP has happened, this is the situation. After sub ESP comma 0x10, this is the situation. Some okay, stack frame. ESP points here now. EBP still, so you got to see how EBP is pointing to the old EBP, right? Everyone clear on this? This happens because of the nature of push. Now call. This is fun. So yesterday, Manu, I think Manu was it who not yesterday, day before. Manu asked me how shouldn't EBP point to old EBP plus one? No, 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 minus one. Why? You pushed the value of EBP, right? Whatever EBP was pointing to, the current EBP ka cell has that value. Like the next dabba is the start of the new stack frame. Going to the last value pushed or the address after it. The last value pushed. Uh, yeah, so that's what. And EBP points to the base of the stack frame, right? Uh, yeah, so at EBP, there is no value of the current stack frame. It is the old EBP. See, it would be better if you just take it as a gospel. Jokes apart, seriously, like this is what happens. Stack frame starts from here. And I will come to how this is helpful now. Call pay, what happens is when you do a call F, so the thing that's happening at EIP is separate. This is code section, this is stack. Uh, Over here you got a call F, EIP jumps here. This is so call F happened. EBP points to something. ESP now points to uh, the old EIP value plus 8 plus 4. I'm not sure what the size of call ka instruction is. Like instructions can have different sizes. Let us assume it is 4 bytes. So the next instruction would be यहाँ पे EIP था. So next would be this. This was old EIP. That so we store this. So Manu, is this clear why ret just reads the value from ESP? I think this should make much more sense now.
Yeah, this.
Yeah, so the reason ret just assumes that ESP points to EIP plus 4, the old the call ka address plus 4 is because when call happened, that is exactly what happened. You did a push EIP plus 4. Note, you are not dereferencing EIP, you are pushing its exact value. So call was basically this. Now ret just reads from this and removes. So I think how stack frames are constructed in conjunction with function calls is very clear now. I am hoping it should be. Yeah. Any doubts, anyone? Please feel free to ask. Mm,
The call F part where you wrote
hmm.
that come like only after that does that like the above statements come, right? The move and the move ESP to
Yes.
EBP to ESP
So
and stuff.
just to be clear, after call F, those moves come here in F because once again,
Okay,
F decides if it has to create a stack frame or not.
yeah.
So yeah, these were some basic things, and we were at addressing mode, right? So how is this helpful? You have EBP pointing to old EBP, EBP minus 4 pointing to old EIP. Can you repeat modes? Sure. Write them down. So there are only two modes so far, three. I am giving reference with respect to push, but it doesn't matter. and negative can also come here in the first case, and this has to be a hard-coded value. Uh, Manu, which part is unclear in this, or do you not remember them?
The third one.
Third one, okay. So you remember this, right?
Yeah,
Yeah,
dereferences.
yeah. So this is basically subtract before dereferencing.
Shouldn't the bracket enclose 10 as well? If that is okay, I assume this is the syntax.
Yeah, yeah, yeah. So that's just the syntax. There's nothing I can do about it.
Okay.
So you
Yeah,
get the dereferenced value and then you push it into the stack.
yes.
Okay.
And this all happens at once. So this is clear, right? Cool. And this is just EBP ka value. So the reason addressing modes are in play, there are a bunch of other fancy addressing modes. I'm not going there because you don't need them at all. Uh, so EBP points to old EBP. EBP minus 0x 4. Yeah, EBP minus 0x4 points to old DIP. EBP minus 0 plus EBP plus 0x4 points to old DIP. EBP plus 0x8 points to first argument. And this is the reason you pushed in the other way. So arg2 comes here, and arg3 comes here. So I think you can get a general formula for argn using this. So for argument n in the current, if you have to get in the current stack frame, if you have to get the value of argument n, argn is equal to something like what would it be? N into 4. Now you can't do this computation in the bracket itself, but it would be so yeah, EBP plus 0x4 plus n into 4. Yeah, EBP plus 0x4 plus n into 0x4. So okay, n star, I'll use star here. N star 0x4. So this is why arguments are pushed in the reverse order. Ouch. This is very itchy. Huh. So if you have to get the nth arg, the assembly instructions would look something like this. Mul EAX, assume EAX already stores n. Okay. Move. Uh, you you can directly reference a val. Okay. You can reference a value n. N is any hard-coded value to EAX. Mul 4 EAX, add 4 EAX, and then if you don't know the value of n, and then you refer to it. Okay, I dug myself a grave over here. So this is only helpful if you know which exact argument you're referring to, because then you can basically use this value and call it x. Let's say call it lambda. So you can do lambda of EBP, direct referencing to that argument. Ignore all this. So this is clear. Similarly, the variables, for variables, it's the other way. EIP is here, EBP is here, uh, and EBP points to here as well. First variable is here, second variable is here, and so on. So for that, can someone tell me what? So for Varan, what would you have to do? Yeah. So what Rishit told is exactly right. EBP minus, yes, all of you are right. Any doubt in either arguments or variables? So I think now we can construct a general picture of more specific picture, not a general picture of the stack. If the current function call is f, EBP, EIP, arg1, and so on, var1, var2, and so on, and ESP points somewhere below, you have no idea, EBP. So I hope you understand why we are using EBP instead of ESP to reference them. What do you think happens if we use ESP?
We won't know how many variables are there.
That's one problem. See, ESP can change around, that's right. Reference place keeps moving, that's also right. You do a push or a pop, ESP changes. Now that is fine if you know if the push and pop is definitely happening, but for, that makes things complicated, true, but like you can still use it. But what if it's conditional? In that case, you have no idea if the push or a pop is happening or not, and then you're just confused. You don't know what to do. The best way is to just use EBP, which is not changing at all because of a push or a pop or a call. Clear? Sriram? Yeah, cool.
Yeah, yeah.
Perfect. Anyone having any doubts in this? Because now it's going to get much worse. I am adding a second variable to this. So you remember this, uh, and I'm not going to do the third form at all because that's not relevant. 0 EBP. What if I add ESP just for the fun of it? So don't guess. There's no point. I have no idea why the syntax exists. Actually, I do, and I'll tell you, but like you'll still laugh at me. Can any of you guess why this is needed? Anyone at all? I know I asked you not to guess it, but like I think it's fairly guessable now. If you don't, this has to be a hard-coded value. But what if you don't know the value? You have to compute it. So you can do something like, as I did above, move so let's say EAX has your some dynamic computation value. Then you move you do a mul 0x4 EAX. You do an add 0x4 EAX, and then instead of referencing it that way, you reference it this way. Push 0x0 EBP, EAX. By the way, this number is optional. If it's zero, you can choose to not write it. Similar to how we did not write it here. Implicit 0x0. So is this much
Will
clear?
the number get
Huh?
added or subtracted?
Added. The number is always added. You give a negative number if you have to subtract.
Like in the previous place, then like where you wrote push 0x10 bracket of EBP, you took a minus sign.
My bad. It should be okay. I'll change it. My bad. My bad. It's always carried with the sign. Okay.
Yeah,
Yeah. Any other doubts in this mode? This mode is like this is the syntax. I'm just teaching you syntax. There's nothing right now of importance here.
So like EBP and EAX, those things make some sense, but like EBP plus ESP plus 0x10, what is its use? I mean,
Nothing.
what does it do physically in the computer?
Nothing.
It's
Nothing.
just for an example.
Yeah.
Okay, yeah. Okay.
Yeah. I should have picked the EAX actually. That's fine. Anyways, so that much. That was a lot of syntax, right? Let's do exploitation. Oh, it's 1 hour already. No, not the fun stuff yet. It's the theory behind exploitation. Sad life. So we'll come to buffers. But yeah, the fun stuff will probably start from the next class. Or it can start from this class, assuming we have enough time, which I doubt. So each of this cell is 1 byte. Okay. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. And there are two more registers that I'm introducing, ESI and EDI. This is called the source index, and this is called the destination. You will see them frequently when strings are being handled. So now let's paint a very generic picture of the stack with strings. Uh, so if I draw the box horizontally, it means it's an 8-byte thing. If I draw the box short, it means it's a 1-byte thing. Just keep that in mind. So this is a buffer, and let's say the string that was stored was A, B, C, D, E, F, G. So in memory, it will be A, B, C, D, E, F, G, and what would come here?
None.
Random
Yeah,
value.
random value or what? Backslash 0,
Yeah,
yeah, null.
yeah.
So do you see a problem here? Hint is, yeah, string greater than 8 characters. So assume your character buffer was size 8. So char s8 is this thing you drew in memory. Yes, yes, yes. We can override the value of EIP. You can do a lot of fun stuff. Overwriting the value of EIP is the beginning of things. Mm, okay, also I might end the class early. I have to go somewhere. So probably right now it's 7:40 for me. So I'll probably end it in like 20 or 30 minutes. Really sorry, but like I don't have a choice. Uh, so char S8 and above it is int X. These are 4-byte blocks. So finally your memory would look something like this. Mm, and this entire thing is S. So and then we do an strcpy. So let's say strcpy. Uh, I don't remember the syntax. I think it's source and destination again. argv1 comma s. Do you all know what argv1 and strcpy are? First of all, uh, how many of you do not know? Ask off because I can tell. Okay. Yeah. Yeah. I think two people so far. I'll tell you anyways. But so the main function. So when you do a dot slash a dot out, so you're all done ls, right? I am assuming all of you know what ls does in the command line. If not, I'll show you. Uh, hmm, ls lists minus l. So forget about the output. The input is what matters. So this is called an argument minus l. And the way it works is, so you have a main function. Okay, syntax. I'll change that. I did not remember it. Uh, hmm, comma argv. Ouch. So so a couple of things. Uh, so argv is an array of pointers to strings. That's fine. Manu and Arnav. And what this means is the argv length. So the total length of argv is equal to arg c plus 2 because it goes from 0 to arg c. I'll come to what 0 stores. So in case of ls, now this thing isn't allowed in C, but like you get the point, right? This is what the zeroth argument of the array is. Hello. First is the file, second is the file location or something. Where? See, I don't forget what is that plus 2 for. Mm, it should be plus 2, right? Plus 1. Plus 1. My bad. Yeah, plus 1. My bad. Plus 1. Shouldn't it be equal? What should be equal? One second, there are a lot of chats. First, see, file location, just forget about it. argc and length of argv. No, right. Indexing starts from 0.
argc already includes the starting zero part also, right? So like if you don't give it anything, it already has argc as one, I think.
Yeah, that's fine. That's why argv will have two things. The first thing is the name of the argument, which is uh yeah, if okay, let's say you call the program as dot slash a dot out. That's it. So argc Manu, hold on. I'll come to that. Not through arguments. Uh, then argv will be two things. Just understand the syntax. This is not C syntax, but you just understand what I'm meaning. The dot slash a dot out, and this will be null. Uh, not an empty string. Not an empty string. Null. Because in memory. Wait. Okay. This is the string in memory. First will be A, second will be 0. Is this clear now? Tell me. Null. Yes. You can assume these ones are. Rishit, you can assume these ones are. Harsha, is this clear?
Yeah, like okay, yeah, fine.
So now do you understand this comment and all of this?
Could you run it on the terminal once if possible?
Sure.
Like just to show the length of argv.
Mm-hmm. See, length of argv I cannot show, but I can do asserts and show you. Uh, Uh, argv is just my command in an array broken by space and an extra null in the end. Yes, exactly. Quote percent s backslash n. Okay. For int I is equal to 0, I less than argc quote I plus plus. Argv of I. Finally assert if you
Can't you even take I equal to argc?
no, I will let me write it. Let me write it. What is this? Main args. So the first value is argc, second value is argv of clear. If you do not believe me, try it with this and watch it fail. See, clear. If anyone has,
Oh yeah.
if anyone still does not believe me, run it on your systems. And after that, there's nothing I can do. Cool. So argv1 finally. Because this assertion would fail, that won't be printed. Should have added a backslash in. Uh, I hope everyone's doubt is clear with this. If you do not understand the code that's written, so yeah, I was very serious when I said read Beej. You need to know C programming in order to understand what's going on. So this is clear right now. argv1. Arnav and Manu, you two had doubt in argv. Is this clear? Cool. So now what's str? Okay, my bad. Hmm. strcpy is string copy. So what it does is, if you have ls, okay, dot slash a dot out uh, a abcd, it will copy abcd from, now abcd is an argv1, it will copy abcd from argv1 to s. Manu, is that clear? So finally it would be looking like, and these would be garbage values. The three other values would be garbage values. Is that clear? Why can't you operate directly using argv1? You can. No one is stopping you from doing that, but not always. See, sometimes, see, in some cases, you have to copy the array because let's say you want to make a copy and operate on it, and you want to store the original as well. So you have to copy the array, right? So C has a lot of dumb functions. One of them is strcpy, another one is printf. Right now, let's deal with strcpy. So you see what happens if strcpy has four letters, it ignores the further ones. It has no notion. So first of all, we did not pass the length of the array s in the function. So it has no idea of where it should stop. So it basically doesn't. So if the function was dot slash a dot out a b c d e f g h I J K L M N O P, or maybe I should shorten it G H I J K L. So this would look like after strcpy has happened, EIP EBP and X, which I am now splitting into four chunks, each having the digit, each having the byte, not the digit. So A, B, C, D, E, F, G, F, G, H. Okay, let's erase one more character. I, J, K, E, F, G, H. Now, yeah, I, J, okay, K, and backslash 0. So, you know, characters are stored as ASCII values, right? Hmm. So, this will be I into 16 power, or sorry, 8 power, the ASCII value of I into 8 power 3 plus ASCII of j into 8 power 2 plus ASCII of k into 8 power 1 plus ASCII of backslash 0, which is 0, into 8 power 0. That will be the number finally. Because each block is 1 byte. Oh, sorry. My bad. I understood. 256. Yeah, 256. Instead of 8, 256. 256 square power 1. 2. What happened? Just tell me if my brain isn't working again. It happens. I am only human. Mine isn't. Okay. No. So, what part is unclear? So, you understood how it happened, right? I, J, K. Yeah. So, the expansion. First of all, you understood how the copy happened, right? So, these are like 4 bytes of I, the variable X, 8 bytes of the buffer S, I'll be ending the class in like 5 to 10 minutes. I'm sorry, but I have to go somewhere. Really important things happened last night. So now when you do an strcpy A, B, C, D, E, F, G, H, I, J, K, \0. Fine. Now I am lying to you a bit over here, but you can assume this is the maximum number, maximum digit, the largest, and this is the smallest. So the number becomes I into something cube plus j into something square plus k into something plus 0 into something power 1 plus 0 into something power 0. What is that something? 256, like Harsha pointed out. Why 256? Okay, yeah. Uh, each of these, as I said before, each of the small boxes is a byte, right? Cool. Yeah. Anyone having doubt in the expansion? Go on. Go on. Go
No,
on.
like yeah, why 256?
One byte is 8 bits. You know, one byte ka maximum value
Yeah, yeah.
0 to 255. So each of these boxes can hold 256 possible values. Then the next
Okay.
box can also hold 256 values. So what will be the combined number of these two values? A into 256, because you overflew into the next box because the first box wasn't able to hold anything anymore.
Okay.
The same way number system works.
Okay, so like if it was initially 4, like before the overwriting, it would just be 0004.
Yes. Now,
Okay, okay.
now I will send you a demo program and instructions on how to compile and run it. So you can try with different values of S, and I will comment it very well so that you understand what's going on in the code. It will be very simple code, don't worry. It will be this only. It basically, long story short, it will be strcpy with an integer. And you can understand how overflow is working. The basic essence would be just this. You overwrite the value of x, so there will be finally something like this. So initially x will be 0. Finally you do the strcpy wala business, and else something else. Cool. That will be the program that I'm sending you. I will send you. I have to write it and check a few things, but yeah, that's pretty much it for today. And your task would be to, why is strcpy not patched? See, if you patch it, you break a lot of existing code. So by the way, there is a secure variant. It's called strncpy. RNCPY. Yeah, Abazar is right. Destination, source, and length. So see, you can't patch strcpy because strcpy, like, see, it takes two arguments, and if you change the number of arguments for strcpy, a lot of existing code would stop compiling. That should not happen. So there is no other way you can get the integer, the length of the buffer. In many cases, you don't know the length of the buffer yourself. You just trust it because of various things. Over here, strncpy takes the length of the buffer explicitly, so it just stops at length. Manu, is that clear? strcpy cannot be patched. There is simply no way. Clear, but still seem it is dumb. I don't even deny it. Okay, it seems dumb from modern standards, but there are justifications as to why this design was done. First of all, it's simpler code because strcpy, because the the buffer can be passed as an argument. Okay, I get your doubt now. So I can have a function f char star s. It has no idea of the size of s, but you can still do strcpy s. Cool. Padding. No, no, no. It's not null. It could be null. It could not be null. The reason is it's just wasteful to set it to null because ideally you are not supposed to read the padding bytes anyways. Abizar, I hope that's clear. Cool. Anyone having any doubts so far? Ask off now.
So we are doing index and then string something, right?
Yeah,
Char star.
int followed by string. I will write to you the exact program. I will give you the compiled binary, and
Okay.
you can test it for yourself.
Mm.
For now, so then you basically understand what this leads to, right? Eventually, you overwrite EIP and EBP. When you do that, you control what the execution would be.
Okay. So like
So,
when I run just index and char s8 and then print of their addresses,
Hmm.
I'm getting S is after X. The
Ha. Pos After X meaning?
I mean, so let's say address of X is some thousand. I'm like getting thousand plus something for the S in and not minus as in here.
Yeah, yeah. So that is the compiler optimizing things for you. That's why I said I will give you the compiled binary. I will give you the code. You need to use some flags to disable those protections. I will do that, and I will give you the example code because
Okay.
you need to figure out a lot of things otherwise. So just trust me.
Okay.
Cool. Is that clear to
so
everyone? Yeah, yeah, go on.
a small doubt, like so, like in the first class, there were like four basic things in the like CPU or something like EAX, EBX, ECX, and EDX, right?
Yes.
And like the ESP, EIP, and EBP are pointers to the positions in the memory, right?
They are supposed to be. Nothing is stopping you from making like storing 1, 2, 3, 4 in them.
Huh, yeah.
Idea Their purpose is to well point to the stack. Yes.
Okay. So like I understood when you said move EBP, ESP, and stuff, but when you said move EAX, that is where I did not understand. What are you trying to do?
Change. Okay. So yeah, move. So move can also take hard coded arguments. So you can do move 0x10 to EAX.
So like, are you writing it into the EAX thing or something?
Yes, yes.
Okay. But EAX and all that stuff and EBP, ESP and all are different, right?
Yeah, they are different registers.
Okay. Those are not registers, right? EBP and
They
stuff.
are registers, bro. Everything is a register in a processor.
Okay.
They just
So the
have their, listen to me. We interpret them as pointers to stack. They work as pointers to stack. As you see, push and pop manipulate ESP, call manipulates EIP. Nothing is stopping you from doing arithmetic in them.
okay, so like all of these are basically that things only, right?
Yes, yes. See, I can have an assembly program whose thing will be move 0x0 ESP, move 0x1 EBP, uh, a- add ESP, EBP, uh, sub EBP, ESP, and basically do arithmetic on ESP and EBP. Nothing is stopping me from doing that. The point, it's just practically useless because you have four other registers which are explicitly meant for EAX and like explicitly meant for arithmetic.
Okay, so there are more than four directories.
There are EAX, BX, CX, DX, 4, EIP, 1, EBP, ESP, 2. As I pointed out before, ESI, EDI, which you will be seeing very shortly, mostly in the next lecture, 2. Then there are some stack segment, code segment. They are redundant registers, data segment, file segment, 4. There are more of these. These are redundant. They are there because 16-bit architecture needed them. Right now we are on 64-bit, so these can hold all of that directly. But
Okay, okay.
there are multiple registers. All of them have different functions. These are meant for string handling. Stack, code, arithmetic. Is this clear?
Yeah, okay, yeah, yeah. Did we use them though, the
Which ones?
arithmetic one?
I mean, I gave examples like EAX wala example above. See, if you do arithmetic, they will be used. I did not use them because I'm not writing assembly. I'm trying to teach you how assembly works.
Okay, yeah, fine.
Can you go to the last thing where you moved a constant to register?
Yeah,
Okay. So what does here happens is the value of EX will be written as 0x10.
yes.
So here the what exactly source and destination mean here? Like
Destination
we
is,
wrote we wrote move EBP ESP, right? In one at one point that move that wrote the value of ESP at EBP or other way around.
okay, this might be wrong. See, I am not I need to decompile and see. I do not remember the exact syntax. Long
Okay.
story short, one moves, you forget the syntax and get the action, please. I think
Uh,
I have fumbled up over there. I think even Manu was confused on just that only, right?
mm.
It is
Yeah.
move RBP RST in Godbolt. Which syntax, Rishit? Rishit, I am assuming. Let's see.
AT&T says move source and destination.
Yeah, that means nothing because you what is source and what is destination? Mm, int square.
In move EBP ESP, it was like ESP is the source and EBP is
Move
no.
RBP is to yeah. So this right.
Yeah.
Uh, yeah. So move RBP to RSP. Let me change 32-bit. GCC. Where is it? GCC 32-bit. 32-bit is where is the 32-bit? Yeah. Are you all there?
Yeah.
So as you can see, move EBP to ESP. Let's say add more options. I'll first of all add. Uh, for those of you who wanted to see arithmetic, here is arithmetic. Now let's hope it does not optimize that out. Otherwise, I'll just return Z. Yeah, yeah. Ooh. First of all, this is Intel syntax, I think. Uh, hmm. I think this might be Intel syntax. So I think we'll just use Godbolt as the reference. And based on that, I'll tell you. I feel this is Intel syntax. Regardless, so as you see, you refer to variables through this, and you first loaded in you first loaded EBP minus 4, that was 10, that was X. X you loaded in register EAX, EDX. Y you loaded in register EAX. Then you did an add. E. So this did, I think, if I'm not mistaken, this did. Uh, I think that did, but it's a comment for fuck's sake. EAX is equal to EAX plus EDX. So you need to be a little bit sure about the syntax. I don't remember. Sorry, but like, yeah, and this is the third variable. So you moved the value of EAX into this. Then you did that again for some reason.
Wait,
Oh, yeah.
when functions return, then how is the return value going back to the call function?
EAX. Yeah, so I did not tell this to you, but return values go through EAX. So okay, that's the last statement. So EAX has the uh EAX, as you can, oh, it's highlighted. That's nice. EAX has Z right now. So you write it to memory, Z. Cool. This is the location of Z, EBP minus 12. Manu.
Yeah, yeah, I'm getting
So then what you do, this since I disabled optimizations, what you do is you load the value of EBP minus 12, that is Z. You load it to EAX, because EAX is how you pass the return value back. Then you do a leave,
it.
and then you do a ret.
Wait, what is leave?
Leave is what I told you, right? Move. Okay, if
Oh,
you people, so yeah, the last two
yeah,
instructions in the call frame, stack frame destruction,
yeah, yeah.
uh, like before ret, the last two, they can be abbreviated to leave.
Okay.
Could you tell the 11th line one?
Where is 11? Move. So EAX is how you ret okay, actually, now clear.
So this is Intel syntax. Oh.
I am not sure. Uh,
So
font
here
color.
the at the
Intel,
tenth
Intel.
line.
It is Intel. Yes, in the 10th line.
Okay.
Yes.
So in 10th line, the EBP minus 12, that is destination, right?
Yes, you can ignore D word PTR. That's not needed.
Minus 12, that is destination.
And that is Z.
Okay, yeah. Okay, yeah. But the EBP minus 12 is destination. Yeah.
And as you
Okay,
can
Okay.
so
see, uh, yeah, go on.
like what is happening is they're taking in values into the registers, operating on it, and giving it back through EAX. Is that right?
Yes, right now I changed it to void, so you don't need to. So there are a couple of things to note here. First of all, ESP subbed 16 because we wanted 16 byte alignment. We wanted that. Why is not relevant. That's the first thing. Second thing is to accommodate. So we also want like the code section to be aligned well. How many is this? One, 2, 3, 4, 5, 6, 7 plus 5, 12. We want it to be a multiple of 4 as well. There are reasons. I am not telling you the reasons. Do not ask me. Uh, if alternatively instead of leave you use the other two instructions that I told you last time, you don't need the no op. But this is the basic essence of it.
What did you say was purpose of sub ESP 16 again?
So the stack has to be 16 byte aligned.
Meaning?
Uh, See, if you sub 12, the next stack that will begin at
Okay, got it.
yeah, so you want it to begin at a 16 byte boundary, but it will instead begin somewhere in between the chunk.
Okay.
That's the first thing. The second thing is this entire thing is also 12 instructions as you see. We wanted it to be a multiple of 4 or 2, one of those two. I'm not sure what the optimization is. I disabled them, but like I think this is a requirement. I am not familiar because I'm not an assembly language programmer. I rarely write assembly, mostly because I don't need to. So you all understand the syntax. So we'll use Godbolt defaults with these flags. I will send you whatever it is that needs to be done. So this should be clear, I guess. In 8085, register A was special because it was inside the A and it could only do the math. The same here. 8085 or 6, I'm not sure. Both. Uh, Interesting. It might be true. See, architecture. It was a specific processor, to be precise. It might be true. I am not sure once again. Uh, I do not design processors either in my free time. Uh, but you should see once again. Let's not go into the specifics. From what I know now, in 64-bit you can do whatever register you want for arithmetic. EAX is just conventional because I think the reasons as Abhizar stated. AX was in the ALU in 8086. Uh, yeah, over here it doesn't matter. I think it's just conventional to do EAX. And if you do, and so Harsha, you had the doubt in line 11, right?
Yeah.
So if you do a return 0, so you see what's happening here, right? The return value is moved to EAX and then returned. If instead you did return Z, the return value of Z, which is this location, is returned.
Okay, yeah, clear.
Cool. So I think that's it for today. If unless you people have other doubts, feel free to stick. I will send you exactly how to generate assembly on Godbolt so that we are all on the same page when we refer to assembly. But I think the stack frame creation mechanism should be clear and how call happens. Any doubt? By the way, can the club buy a Flipper Zero just to play around with it? Seems like fun. See, we want to buy chips. I need to be there in India to have a discussion and buy. No one is in campus right now, and I'm not even in India, much less campus. Uh, we had plans for Flipper Zero. I think we chose some other boards instead, and so that we could make our own Flipper Zero kind of tools. Yeah, like basically that. That's the. I can get one. That's not hard. What's the cost? I don't remember. Why India, yaar? Flipper Zero in India. Let's see. How much is it? 30. Oh, oh my God. Yeah, we can buy one regardless. Alternatively, we can make one. We have a bunch of archives lying around. Uh, in any case,
Wait, what is it?
it's a tool for like fucking around with Bluetooth and Wi-Fi and RFC
Oh,
and other things. That's it. That's all it does. We wanted to make one ourselves just for the fun of it, but we never got the time. Yeah. So as of now, the session is ended. If you people want to leave, you can leave. If any of you have doubts, stay back and ask them. I'll be there for like 5 to 10 more minutes. I'm already half an hour late. Bye. Bye. Vibhu also left. Bye. 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 Bye.